Happy Friday. Anyone has any questions for me or Miss Minion? That means a no, I guess. All right. So it's 11 o'clock. So let me quickly review what we did in the last class. And in the meantime, if somebody is running late, they can also join. So last time we talked about correlation. We were working on chapter 2. So we started with the correlation, and we also talked about what is correlation. Before looking for the correlation, what are the things we need to keep in our mind? So when we are looking at the relationship between two numerical variables, we are using scatter plot. So once we make a scatter plot and we know that that relationship is linear or it is taking a form of a line, then to measure the strength of that linear relationship, we use correlation. So correlation measures the strength of a linear relationship, and we use the symbol R or rho to measure to represent that correlation. Excuse me. We also talk about the formula, how to calculate this correlation numerically, or how to calculate this correlation using calculator. The information is provided in your Stat 108 notes, chapter 2A, or you can also look at Launchpad, where you can see TI 8384 technology manual. And yesterday I was working with one of the student from Stat 271, and he mentioned it to me that he can calculate that using TI 36 also. So if you do not have TI 83, 84, and TI 36, I think it's 15 or 20 bucks. So you can use that also to calculate. And there I think you have to do one variable statistic, two variable, and then you can calculate that part. We also discuss the what are the properties of correlation. So let me just quickly go over with that. So when we talk about correlation R, it is a number between -1 and 1. So +1, perfect positive correlation, negative perfect negative correlation, R equal to 0, no correlation, closer to 0, weak correlation, closer to 1, or -1, stronger correlation, or the strength is better because it's getting close to perfect positive or perfect negative. If we are saying that R is 1 or R is equal to -1, we cannot say this is stronger and this is less stronger. They are both talking about 1. This positive and negative sign tells you which direction. If you are talking about positive one, you have upward linear direction, and here you have downward linear direction. Distinction between explanatory and response variable. If it exists, if you know which one is explanatory, which one is response, plot your explanatory on X and response on Y. And if you cannot make the distinction, you can still find the correlation using this X and Y. If you don't know if it's explanatory or response, you can still plot one here, and you can see there is a linear relationship or not. So correlation does not make a distinction between explanatory and response. Explanatory variables are also called as independent variables, and response variables are called as dependent variables, because you will not get a response until there is an explanatory variable. So they are not dependent on anything, but response variable is dependent on my other variable, or you can say that Y is dependent on X. You cannot get a response. If I ask you a question, then only you will give me a response. You will not give me a response if no question is being asked. So response variable is dependent on explanatory variables. So it is also called as independent and dependent variables. And correlation, again, when we are talking about correlation, correlation needs your mean X, your mean of Y variable, standard deviation of X, and standard deviation of Y. Because when we calculate correlation, we find the mean. We find the standard deviation. Same thing, we find the mean of y, mean of standard deviation of y, and then plug everything in this formula to calculate correlation. So if we look at this, we cannot calculate correlation if we don't know what my mean of x is, what my mean of y, standard deviation. So you need to know these four things to calculate your correlation. So when we are talking about these, and the fifth one is your correlation, sometimes we also say that 5-number summary, but this is actually not actually 5-number summary. We learned 5-number summary in chapter 1, but here also we can say that when we are talking about linear regression, we need to know these 5 things. Knowing the value of R alone is not enough. If you know R is this, that R is not a complete summary of your numerical data. You need to know these things also. Excuse me. And since we are using mean and standard deviation, both mean and standard deviation, they are not resistant to outliers. Mean will change or standard deviation will change if there are outliers in your data set. So R is also not resistant to outliers. If there are outliers in your data set, your strength will get affected, or you can say your linear strength will get affected. So your correlation will be impacted, or it will change if there are outliers in your data set. So that's why when we talk about actual 5-number summary, minimum, maximum, they are resistant to outliers. They do not, like when we talk about median is resistant to outliers, and Q1, Q3 are. But here, since we use mean and standard deviation for both variables, they can change similarly. Your R can get affected with the outliers in your data set. And these are the points that we just discussed. Correlation, when we use both variables, numerical or quantitative. If they are not quantitative, we cannot talk about correlation. That means we are talking about categorical variables. You use categorical variables, you can make scatter plot, but that scatter plot will not tell you any relationship between those two categorical variables. So we use different concept, or we use something other than correlation to see if there is a relationship going on in between two categorical variables, and we call it as two-way tables, which is the next topic once we are done with correlation and regression. Correlation does not describe curved relationship. Correlation is a name for linear relation. So anything other than linear is not we are not talking about correlation, no matter how strong that relationship is. It is not correlation. Correlation is not resistant. It can be strongly affected by few outlying observations, and it is not a complete summary of two variable data set. Or you can say that correlation is not a correlation alone is not enough for bivariate data set. We need to know the mean and standard deviation for both variables. Our next topic is least square regression line, and your first homework assignment 2.1 to 2.4. You can start working on that. I think it's due on 8th. Regression line, least square regression line, prediction, facts about least square regression line, and how correlation and regression are similar, how they are different, how can we, when we are talking about correlation, can we do the regression? And if we don't have correlation, can we still work on regression? So we'll talk about this. Regression line. A regression line is a straight line that describes how a response variable y changes as an explanatory variable x changes. So think about first step, you start with a scatter plot. In a scatter plot, you look at the form, direction, strength, and outlier, 4 things, and you see there is a linear pattern going on. Once you know there is a linear pattern going on, and I know what my explanatory and what my response variable is, and I want to find the value of y to see how my x, when my x changes, how does my y react? Does it stays the same? It goes up or down, and going up or down how much? So we can draw a line and try to predict or the values of y using the values of x. But how to fit that line inside that scatter plot? So when we are talking about scatter plot, see the linear pattern, you can fit a line. And again, when I'm saying you can fit a line, we cannot fit that line manually. We use some software or to see or to fit the line inside that scatter plot. Once that line is there, so look at this one. So I have a scatter plot and I see a linear pattern, and I fit a line inside that using a software. Once I have this, now it says that we can use this regression line to predict the value of y with the given value of x. So how my x is changing, if I'm increasing x or decreasing x, what happens to my y? Or if I want to see what is the value of y when x is 50 or when x is 70. So I can predict that values. So when I'm saying I'm predicting that values, so that predicted value is my response variable. So I can predict the value when I know that this is my response variable. And the other one is my explanatory. So I'm using my x as explanatory. So when we talk about regression, the important thing is definitely the correlation is going on. That's how you can make a line. But when you are predicting something, you should know what you are predicting, right? If you are predicting, here in the case, it's how many birds are predicted. So you know that you are looking for the birds. So prediction is on the bird. So that is your response variable. So distinction between explanatory and response variable is must when you do the regression line or when you do the prediction. Because if you don't know what you are predicting, you might be predicting the number of percentage of adult returning instead of number of new birds. So the distinction between X and Y, or you can say the explanatory and response or independent or dependent, should be clear. Otherwise, your prediction will be wrong because you might end up predicting the value of your explanatory variable using response. So, which is not the case in the correlation. Correlation still gives you a linear relationship, but when we talk about a regression line, the distinction or the you should know the difference between, or you should know what you are predicting, and that is your response, and other is your explanatory variable. Again, if there is no correlation, you cannot do regression, because correlation, you see a linear relation, right? So when you have linear relation, then only you can fit a line and then try to predict the values. But if there is no correlation, no matter how strong the relationship is, you cannot do regression. So here, let's come back to this example. So if 60% of adults return, how many birds are predicted? If we just look at this scatter plot and not doing any math, so if I'm looking at my x, which is 60, according to the question, so my x is 60, how much is the value of y, or the number of birds? So I will go and see where is this um, point on my line, and I can see this value, and I see that when my x is 60, my y is between 13 and 15, so it's somewhere close between 14 and 15. This is the value that I just get it from the scatter plot. But there are ways to find the exact value, because here, if I say, let's say it's 13.9, somebody will say 13.7, 13.2, 14, 14.9. So we all will have different estimate, but we know definitely it's between 10 to 15. But what is the value that we all get at the same time using this information? So we need, when we talk about prediction, we need some values to do the prediction. And what are those? So we need to make a regression line, or we need to, when we need to fit the line, we need to have a regression equation, or an equation of the line. So in your previous courses, middle school, high school, or other course, we learn about the equation of the line, right? Or some courses we learn that this one. So we are using the same concept. So when we are saying equation of the line, we are saying y equals mx plus c, where m is your slope and c is your y-intercept when your x is 0, right? Same thing if I'm looking at this one, my slope is b and a is my y-intercept, and here this is x. So my slope is a and b is the y-intercept. We are using the same concept, but since we have learned different notations, so we are changing it a little bit. But again, that is just for you to understand. You can use any of these. Do not use all of this together, just pick one. When you work on calculator provides you both options. So you need to pick one. If you're picking this one, make sure whatever with the x is your slope. So if you're picking this one, then your slope is a. So it will change. Here your a is y-intercept, here it's slope. So we are using the same equation. Instead, we are using that as b0 plus b1x, where whatever with the x is my slope, and this is my intercept or y-intercept. And again, what is y-intercept when x is 0? Let's say this is my equation of the line. So if my x is 0, where the line is touching the y-axis, and if I'm looking at the slope, I'm looking at rise over run, how much it's going up and down. So b0 plus b1x, b0 is your intercept, b1 is your slope. Now we can say that we are talking about the equation of the line. Same thing, y equals mx plus c or a plus bx, ax plus b, same exact concept. Nothing has changed, just we change the notations. And again, as I mentioned, this is in the slide. If you want, you can use this notation for your reference. You can use this or this, whichever is making sense to you or whichever you are used to of doing it. So now we are predicting the values of y. So when we put a hat on top of a y, we say that it is the predicted value of y. So this we say y hat or the predicted value of y. So y0 b, this is your equation of the line. And now I'm predicting the value of y using what is my y-intercept, what is my slope, and what is my value of x. So when we are using this equation and using x as 60 in the previous example, we all will get the same value. Now we cannot say mine is 13.8, somebody is 13.9, another one is 14.3. So because we are just looking at the scatter plot and just guessing our values. But when we use this equation, we all will get the same result until unless we do something wrong in the calculation. So here, when a scatter plot displays a linear pattern, we can describe the overall pattern by drawing a straight line through the points. Fitting a line to the data means drawing a line that comes as close as possible to the points. And again, that's why we use technology to do that. And this is the equation of your regression that we are going to use. And again, this is your y hat. Y hat means the predicted value of the response variable for a given value of x. X is the value of your explanatory variable. B0 is the slope and B1 is the intercept. And again, what is slope? The amount by which y changes for each unit increase in 1. If x increases from 1 to 2, what happened to y? Is y increasing or decreasing depending upon if you have positive linear relationship or negative linear relationship. An intercept when your x is 0, so whatever the value of intercept is, that is your value of y. Because if your slope is 0, this is the x value is 0, then slope will become 0, and then intercept is the only value you have. Questions? Everybody good with the least square regression line? Because we will have questions where you are plugging the values and solving for that. So we will do an example. Least square regression line, because we're trying to predict the value of y and we want the regression line to be as close as possible to the data points in the vertical direction. We use least square regression line, LSRL, if you see that talks about least square regression line. And this is the standard definition of your least square regression line. And I think I mentioned again earlier also, in your homework, quiz, and test, there are not only numerical questions, there are conceptual questions also, where they are testing the knowledge of the concept. And sometimes you get two answer choices very, very close. So make sure read them carefully what exactly it's saying. So here says the regression line y on x. And if you have the same definition, if it says the regression line of x on y, then it's not the same thing. Is the line that minimizes the sum of squares of the vertical distances of the data points from the line. And if we have to draw an explanatory variable x, response variable y, then this is the equation. And if I say this, so that means I do not have the distinction between x and y, and I end up predicting x instead of y. So this is not correct. So we are coming back to the same example, predicting the number of birds, and now the equation of the line is given to us. So if this equation of the line is given to us, let's see what is given to us. This is y hat. So this is what we are predicting, right? Let me write it better. What do you think this value is?
The intercept?
The intercept. And let's put that equation here on the top so this is the intercept. What about this?
Slope.
It's the slope. And see that in our equation, this is positive, but here I see negative. So that means my regression line is linear direction in the negative side. So my slope is this, and this is x. And now I'm predicting the value of y looking at x, where my x is 60. This is given to you in the question, right? So plug that 60 and solve. And when I plug this, no matter what, we all should get the same answer because we have the same intercept as well as the same slope, right? Now look at this. The slope is negative. That slope tells me that I have a linear regression in the negative direction. And when r is negative, let's say 0.92 something, this also tells me that the strength of the correlation is negative 0.92. So it is telling me that it's in the negative direction. So write a note to yourself that r and slope, which we are using as b1, they share the same sign. They have the same sign. So if you know one, you can find the other one. If you know the correlation is negative, but you don't know if the slope, when you are calculating, you can see that if the value of r, you have the values will be different, but the sign will be same. R negative, that means I have a negative slope, or negative slope, that means negative correlation, or same thing for the positive. Okay, now let's predict something else. So now I have a chart and there is a fitted line. And if you see that fitted line, this is the strength is, if I look, all the points, almost all the points are on the line. So it is very, very close to one. Positive one, right? It's going in the upward direction. So as the value of x or explanatory or independent variable increases, I see the value of the dependent variable also increases. So there I can see that there is a very strong correlation going on. So if there is a very strong positive correlation going on, can I predict the value of y using the value of x? So I know my x is, or my explanatory variable is age, and my response variable is height. Independent, dependent, I know I'm predicting height, so height is my dependent variable. Now, this it says that can you guess her height at the age of 42 months just looking at this scatter plot if you do not have the equation of the line? Yes, the same way how we did it before. 42, see the point on x, and the value is here. So let me just write 87, 87.1, 82. I don't have the equation, so the best I can do is between 85 to 90, let's say 87.5. So everybody has their own guesses depending upon this scatter plot. Now the question is asking, can you predict her age at the age of 30 years? So 30 years, first of all, my age is in month. So if I'm doing in years, I need to convert that 32 into years, right? So multiply with 12 and you get that. So you need to extend this and then you can predict the value. So let's look at the equation. The equation is given to us. So y hat is this. This is my intercept. This is my slope, and I can see the sign is positive, which I can see here. I can see an upward trend, so upward correlation. So now the height at 42 month is this. If you move 42 here, you solve, you get this value. And again, height is in centimeters, so 88 centimeter. Now you look at the age in 30 years, and you might be seeing that now these points are very close. And why? Because now we converted it into months. And then we are going further. Earlier we have only up till 65 months, and now we make a up till 390. So they are all close because they are between 30 to 90, and which is our here 30 to 65. We have these points, so that's why these points are all close. And it again depends what you are doing, how much you are keeping the interval size. Height at the age 30, looking at this, is 209.8 centimeter. Do you agree the height of a person can be that? Looking at this, what do you say, this scatter plot, can no. And any other comments or any other answer that you think of? Why no? Why yes? So think about that. So now we are saying that the way this chart is going, if I'm looking at this chart and keep on going, then predicting the height will be 209.8 centimeter, which will be 6 feet 10.5 inches. If this is the pattern, and this is just the regular pattern that's given in this chart, then that means no matter what, you keep on growing at the age of 30 also. And we all know that we stop growing at certain age. Our height does not grow after certain age. But looking at this chart, when I'm trying to predict, I predicted the height to be 6 feet 10.5 inches. And if I follow this, then I can say that we all will be tall and we all can participate in the basketball games, and if we have such a good height. So again, when we do prediction, we need to be careful about few things. When we try to predict something far outside the range, it will give us bad predictions, and that is called your extrapolation. So here we are suffering from extrapolation because we are trying to predict something outside the range. So we did up to 30 months, 40, 50, 65. We can do more. So we know that at the age of 18, 20, and looking at this chart, we predict the height at the age of 30. What about at the age of 50? It will be 12 feet, 15 feet. At the age of 60, then it will give us false predictions. So when we do predictions, it's not necessary that all the time we have correct predictions. We are predictions will suffer from few things, and one of them is extrapolation. So extrapolation gives us fake results or not correct results. So when you work with the prediction, make sure that your prediction will not suffer from extrapolation. That's one thing. We will talk about more things later also. Fact about least square regression line, we talked about few facts before that we need to know there is a correlation. We need to know there should be a distinction between explanatory and response variable. One important thing, the least square regression line always passes through the mean of that bivariate data set. If you have a least square regression line, your mean of x and y will be somewhere on your line. So your x bar, y bar should always be on the least square regression line. And a change in one standard deviation in x corresponding to change in r standard deviation of y along the regression line. So let me explain this part. So we say that y hat is b0 plus b1x, or you can say that y is ax plus b, or whatever you are using. So when you are using b0 plus b1x, in the example, b0 and b1 is given to us, and we are just plugging the value of x to find that. What happens if b0 is not given or b1 is not given? And we have x. So first thing, we need to calculate b0 and b1. So we need to do some math. So what is b0? And again, b0 is your intercept. So if you're finding the intercept, you need to use for mean of y minus the slope times x bar, or mean of x bar. So again, when I said that R is not the complete summary, you need to know your x bar, y bar, sx, sy. That's why you are going to use all this to calculate b0 and b1. And this formula is not in the slides, so I'll really appreciate if you will write it down. It is on Stat 108 notes though. And b1, this formula is in your slide. b1 is r times sy over sx. So slope is your correlation times the standard deviation of your predicted value. Remember this is sy, not sx. And then you divide with sx. The sy is the standard deviation of your y and standard deviation of x. So let's say you have the value of x bar. I'm just taking some random numbers. Then if you are solving and R is 0.77, so you can calculate, if you have this information, you can plug this information to calculate your B0 and B1. And please take a look at Stat 108 Chapter 2B notes. There are some examples solved, and there you will get all these formulas there. This one you have in the slide. We don't have this one, so write that down. So once you know your B0 and B1, you plug that B0 and B1 here, and then you can find the value of your predicted value, or find value of y, or response variable, using the value of x. Again, if it is given straightforward, you can plug. If it's not given, we know how to calculate mean of x. We know how to calculate mean of y, standard deviation, So that's why I'm saying that make sure you start using calculator or technology. Again, technology is good. Use any software, Excel or anything. But again, for the exam, you will only get to use calculator. So make sure you know how to use that. All right. So this is given here, and you can write B0 is y bar minus. This is what I wrote here, right? Yeah. And again, you cannot calculate your intercept until you know your slope. So first thing, you need to calculate your slope to find your intercept. Okay. So correlation and regression, how they are related, how they are different. Questions, by the way? No? All right. So least square regression looks at the distances of the data points from the line only in y direction, because we are looking for the response variable, and response is in y, and that's why we said that the distinction between x and y is important. As a result, the variable of x and y play a different role in the regression. But in correlation, even though you do not know x and y, you can still find your value of r, or correlation. Even though correlation ignores the distinction between x and y, there is a close connection between the correlation and regression. And what that correlation and regression connection is, the square of the correlation, r square, is the fraction of the variation in the values of y that is explained by the least square regression line, y on x. Or in simple word, you can say that r determines the success usefulness, or you can say success rate of the regression line for prediction. So r square, r is your correlation, and when we do the square of r, we call it coefficient, square of the correlation, fraction of the variation, and R, we say that correlation coefficient. This we call coefficient of determination. So don't get confused with the words. When we are talking about R, we are talking about correlation. When we are talking about R square, we are looking for how good fit a line is. So when we try to fit a line in regression line inside that scatter plot, inside that linear pattern, after seeing there's a correlation, how good fit that is, and that value will help. R square value will help us. If you know R, if you know how much is the correlation, and when again I'm saying if you know R and you know that which is your explanatory and response variable when you calculated R, then you can calculate R square just doing the square of that. So if my R is 0.77, I can calculate my R square by doing the square of that. Now, if I know R square, can I calculate R? Yes. Okay. And how to do that? We just do the square root of that. If I know my R, I can do the square. But other way around, if I know my R square, I can do R also. But make sure when you do the R should be a number between this and this. Right? It should not exceed that. And again, when you do the square root, let's say this, 0.64. If my R square is 0.64, can you guys help me to find the value of R?
0.08.
Okay, and when we do the square root, we get positive and negative values, right? So when I'm saying, when I'm doing the square root, I get positive and negative value. I cannot take both when I'm talking about R, right? So either it's positive or it's negative. Now, how do we take which value of R, positive 0.8 or negative? If we are looking, if we have no information, look for the value of slope. If you have negative slope, then pick the negative value. If you have positive slope, pick that. If you don't have slope, you must have scatter plot. So look at the scatter plot. What kind of linear pattern you see, positive or negative? What is the form? And then accordingly you decide. So when you have R, finding R square is easy. You just do the square. If you have this 0.08, positive or negative, you do the square, you get positive. But when you do the square root, you get both values, positive and negative, and you cannot take both. You need to pick one. And if you are picking one, you need more information. So look either at the scatter plot or look at the slope. And that will give you the correct value to pick either this or this. Questions? And how much time we have? 12 minutes. So let me just show you one more thing. I hope I have that. So in your, let me talk about that using the, so Lee, sometime like when we work with linear regression and in your homework assignment, there are questions when you use a software and you get the results using that software. When you get those results, how to read those results to make the equation of the line. So let me just quickly cover this and then I'll talk about that. Excuse me. Cautions about the correlation and regression. So what are the things you need to be careful when you work with correlation and regression? We need to look for residual and residual plots, outliers and observation, lurking variable, correlation and causation. Residual and residual plots, again, when we try to predict a line, when we try to fit a line, let's say I fit this line, or let's say I fit this line. So this is my observed point in the scatter plot, but what is the predicted value of that when there is a line? So the actual point that I have it is called your this is your observed point, and this is your predicted one. And the difference between observed value and predicted value is called your residue. So residuals, and again, we can make residual plots using, again, technology, and that can be in either direction, above the line, below the line. So if you are looking for this one, And this is the predicted value. Sometimes the predicted value is more, sometimes it's less, depending upon if the point is below the line or above the line. So residual is the difference between observed value and the predicted value. And here you can see the exact definition for the residual. It is the difference between the observed and the predicted value of the response variable and the value predicted by the regression line. And again, you are predicting the response, the predicted value of the response variable. So y minus y hat observed predicted. And when you make the residual plots, again, residual plots, we cannot make it by hand. We use some kind of software. And when we work with the residual plots, you can see the scattered around the zero. That means it is a good fit. And then you can see still there are two outliers in your data set. Ideally, there should be a random scatter around zero, and residual plots suggest deviation from a linear relationship. And let me look. All right, so let me share the Canvas screen with you guys so that we can discuss about that. So it is on your Canvas. If you look at this one, least square regression PDF, and these are the results that when you use any software, how to find when you have the data, you try to put it. So you can take a look, and if you want, you can use any software, take the data set and work on that. And this is how you get the results. So when you get the results like this, how do you read this result? So in the result, if you see that, it gives you the value of r square. And that is what we just did for the regression line, r square. So you don't have to calculate it manually, you get that value. And then it says that adjusted r square and I squared predicted. So you take this value. And when you see here, it says that coefficients, and then you see it says the term constant and NEA. So this is according to your example. So we have this is given to us. And then we are looking for. So when you have this value, just look for the first column where it says coefficient. And then again, how to read those results to make an equation of the line. You don't have to do anything manually. You have big data set. And if you are working with that data set, doing manually, you calculate your x bar, you calculate your y bar. So you have x and y. You calculate x bar, y bar, then you calculate standard deviation for x bar, y bar, and then you will look for the correlation. Again, it's mathematical work, but when you are using the software, it gives you everything in this result. And how to read those results and write an equation of a line. And why am I explaining? Because you have questions in your homework assignment where you have to read the result and just pick the right answer. So how to make the equation? So this one is your constant. It says that constant. So this is your y-intercept. And this is the value of your slope. So when you're writing the equation, it is, so fat, you're predicting the value of fat equals, so first write this is your B0 constant, and then this is your slope. And you see there is a negative sign. So you have negative linear association, or you have negative correlation here. And again, it says that NEA instead of X, because that's what your X variable or your explanatory variable is. So some of the questions in your homework assignment, you don't have to do any math. You have to just read these results, and then you need to pick the right answer from there. And some of the question, like here, it gives you the regression equation. I just want to make sure that you understand where is this coming from. And this is, here are the examples that we just talked about. If r squared is given, how to find your r, and if it's positive, negative, then you need to see what is, so this value is given to you in your result, you get this value, r squared is given, Again, we convert it into decimals if we are looking for r. And then why did I pick this negative? Because I know my slope is negative. Because when I do the square root of this, I get both positive and negative value. So if I'm doing the square root of this part, right? So I get both positive and negative value. And why did I pick the negative one? Because I know my slope is negative. So it gives me the hint that I'm talking about negative linear pattern. Questions? And here is another example. And then you can see that the value of r squared is given, your constant. And if you have to make an equation, so this is your constant, and this is your b1, and then again b1 with what your variable explanatory is, write that and make the equation. So that I want to make sure that you guys understand, because you will see that in your homework assignment. And let me see if I can quickly open the homework assignment. And by the way, if you have some problem when you work with your homework assignment, you go on Launchpad and it does not open, make sure you clear your caches and cookies, and the information is provided on your Canvas page. So take that look and then use that or follow that. So let me open your 2. And we covered up till 2.4. So hopefully you will be good to do that part. Here. So this is what I'm talking about. If this is given to you, how do you read? If you need to make an equation, you know that r square value is given to you. So you have that r square value, 0.02825, 82852. So if you need to find r, you can find r. And then you need to see if it's positive and negative. Go back and you see if it's negative sign here. So that means it's negative correlation. So, and then this is your intercept, and it's written to here very clearly, intercept. So that is your value of B0. This is the value of B1, and that is your explanatory variable. And then go back to your question and see what is your response variable. And same is given here, and it's asking you there is a negative association between this and this, and I think I kind of gave you the answer for that. Yeah, so I guess that's it. And make sure you read the question carefully, like sometime like this, like, do you think there is a linear relationship going on? Is it positive, negative? So see and think about that. What is linear relationship? How does it look like if there is an outlier in the data set? And again, we are not done yet. We are going to talk more about it in the next class also. But if you guys have any question at this point, let me know. So if not, so let me just quickly talk about the last topic, outliers and influential points. An outlier is an observation. Let me share my screen. So an outlier is an observation that lies outside the overall pattern of other observation. And we talk about this in the earlier chapter also. Outlier in y direction have larger residuals. And again, we talk about residual is the difference between your observed value and the predicted value. All outliers are not influential. Outliers in x directions are often influential for least square regression line. And why? Meaning that when we remove those points, it would change our regression. It would change the equation of the line. And here is an example. So here we have two outliers, 18 and 19. And if we keep those, we have this equation. And if we remove those, my equation of the line changes and the value of r square goes down. So outliers influential influential outliers are not all outliers are influential. Keeping or removing if they change your regression line, if they then they are influential. Lurking variables, again, lurking variables are those variables, they are neither in your explanatory nor in your response variable, but they do affect your response and they do affect your results or response. I guess it's time, so I will stop here, but at any point, if you have questions, let me know. So your homework, I don't exactly know when it is due, but if it's due on Monday, then make sure that you work on this one weekend. And I'll see you guys on Monday. Any questions? Let me know. Have a wonderful weekend to all of you.
Thank you.
Thank you. See you guys on Monday.